Howdy gang, it's good to see you all. I hope that you're having a pretty stupendous, outstanding, and fun-filled Friday so far and that you're looking forward to the weekend. At this point, you should all have your Google Chromebooks in front of you. Okay, I plan on the class period you working silently. Okay, we're going to go ahead and put our earphones in so that there's not a bunch of me talking around the classroom. And in the meantime, you can go ahead and take out your 7.3b notes, okay? And I'm going to go through and talk you through some of this stuff on Monday. Okay, we'll have a quiz over radicals and what we've learned over the beginning of chapter 4. Okay, so on Monday, I've already looked at 7.1 and 7.2. I'll look at the remaining assignments as well as look at these notes, and I'll give you a grade for these notes on Monday. So I want to make sure that you're following along well, okay, and have all this filled in on Monday when I come back and you're ready for the quiz. If you have any questions at all, don't hesitate to send me an email over the weekend, okay? If you're like, I'm super confused on this stuff, okay, send me an email, and I'd be happy to give you a little explanation beforehand. So go ahead, take out your notes now, and do the warm-up from 7.3b, okay, operations with radical expressions. You could go ahead and pause the video and then try the warm-up on your own real fast. All right, in the warm-up here, you see a division problem with a radical over a big fraction. Okay, it's one big square root sign. We're going to go ahead, because of the numbers 25 and 121, I like those numbers, okay, those are good numbers for us here. We're going to go ahead and split that up into two radicals instead, a square root on top and a square root on bottom. Let's do that now. So now you get a look at the numerator individually and the denominator individually. You've got a 25 up top and an x squared up top. Okay, those are two very happy numbers for us. Those are what we call perfect squares. Okay, 25, the square root of 25 is 5. So go ahead, circle that 25 and take one 5 out because that's made up of two 5s. Square root of x squared, that's considered two x's. So anytime I see 2 of something, I can take 1 out. So take out 1x. And then on bottom there, you also see two perfect squares. Okay, you see 121. Okay, and y to the 4th. Those are both perfect squares. The square root of 121, that's 11. So you can take out an 11. And then y to the 4th, okay, that's y squared, right? Because we cut those in half. Okay, and that's what you should get for your answer to warm up problem number 1. Number 2, that's a little bit different, okay? Instead, that's a radical up top and a radical on bottom. 45 and 5, those are kind of funky numbers. But let's instead write that as one big square root and then simplify the insides. One big square root instead. Well, 45 over 5, okay, 45 divided by 5, that simplifies. That's a 9 over 1, so you could go ahead and simplify it to look like that. The square root of 9 over 1. And then up top here you have 3 x's, x times x times x. And then in bottom you have 1x. So 3 up top, 1 down below. Take 1 away from each. Okay, and that leaves 2 x's up top. Make that look a little bit nicer. That's the same thing as square root of 9x squared, because that's just over 1. And we can simplify that. Okay, the square root of 9, that's 3. And the square root of x squared, that's x. And that's your final answer there. Go ahead, ask your partner if you have any questions. So far, we've looked at two things, okay? We've looked at what happens if I multiply radicals together. what happens if I divide radicals? Okay, that's kind of the easy way of doing things. The last thing we're going to look at in terms of radicals right now is, can you add them or subtract them? You know that if you add two real numbers, okay, you get the sum of the real numbers. 5 plus 11, that's 16. Because you can add those, they're what we call like terms. They're real numbers. Okay? You can also add radicals, but you got to say it the right way. Really what you're saying here, if you look at this first example, is 6 root 7s plus 4 root 7s. Okay? You've got 6 root 7s plus another 4 root 7s. Think of it in terms of x. 6 x's plus 4 x's. That's 10 x's. Okay? The x didn't change at all, and here it's the same exact thing. The root 7 won't change at all. 6 root 7s plus 4 root 7s. In the end, is 10 root 7s. They stay as root 7. You don't add the insides like you would if you were multiplying. When we multiply them, we multiply the insides. Here, adding or subtracting, those insides are going to stay the same if I'm adding or subtracting them. First things first, on this example number 2, is cross out the x after the 7 because that's not supposed to be there. Okay, I just went to my 7x and I just made it a 7. That x isn't supposed to be there. Who wrote this? Funny way of reading this one, we're going to do it the same way. This is 8 cube root of 2's minus 7 cube root of 2's plus 5 cube root of 2's. If you want to, just ignore the cube root of 2, replace it with a letter, okay, or a fruit, like an apple or something. You've got 8 apples minus 7 apples plus 5 apples. 8 apples minus 7 apples, that's 1 apple, or in this case, 1 cube root 2, plus 5 cube root 2's. And that gives me a final sum of 6 cube root 2's. Okay? Assuming whatever's on the inside looks the exact same, then you can do this very easy. It's just adding like terms. You're adding 8 of something minus 7 of that same thing plus 5 of that same thing. It's going to give you that same thing in the end, but a different number of them. You can skip example number 3. Go to the next one. I hate to break it to you. It's not always this simple, all right? But here's what we're going to do. Sometimes you have to simplify first before you can add or subtract. Like number 4. Number 4 says 3 root 8's minus 5 root 2's. A root 8 is not the same as a root 2, the same way that an apple is not the same as a strawberry. Okay? This basically says 3 apples minus 5 strawberries. And those don't mix. Okay? They're not what we call like terms. So you can't add or subtract them. You can't add apples to strawberries like you can't add x's to y's. Same way, you can't add root 8's to root 2's. So we got to simplify it first. Let's simplify the root 8. Let's simplify it. All right, breaking down root 8. That's a 4 and a 2. That 4, that's 2 2's. Actually, don't even break down the 4 because it's a perfect square, so you can take it outside. Well, sure, you can break it down. It's 2 2's. When you see 2 of something, you can take 1 out. there's already a 3 out there. So it's going to join the 3 with multiplication. That's 3 times 2, which is 6. But there's still 1 2 left inside. So it's 6 root 2. 6 root 2's minus the 5 root 2's from the beginning of the problem. I just simplified the first one. 3 root 8. 3 root 8 is the same as 6 root 2. Now you got 6 root 2's minus 5 root 2's. Oh. 6 root 2's minus 5 root 2's. That's a total of 1 root 2. 6 apples minus 5 apples is just 1 apple in the end. Okay, it simplifies to 1 root 2. And if you want to ditch the 1, you can ditch the 1. There's just 1 root 2 in the end. All right, look at example number 5. The insides aren't the same, and until they are, I can't add them or subtract them. So we got to break it down first. Let's fix the first one. Let's fix the first one. That's 16y to the 4th on the inside. Note the little 3 on the front. So I'm looking for 3 of something to take 1 out every time. Break down your 16 first. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. 3 of something means take 1 out. That's 3 2's. 1 gets to come out and 1's still left inside. There's already a 5 out there, so they'll combine. 5 times the 2 that just came out is the cube root of 2y to the 4th. The other 2 didn't have enough to come out, so it's still stuck outside. Let's fix y to the 4th now. Y to the 4th is the same thing as y cubed times y. Why do I write it y cubed? Because I'm looking for 3 of something to take 1 out. 10 times the cube root of 2y cubed times y. If I see 3 of something, I can take 1 out. That's y cubed. So I get to take 1y out. There's still 1y left inside. 10y times the cube root of the 2y still left inside. 10y times the cube root of 2y. What am I adding that to from the beginning? Plus 7 times the cube root of 2y. Well, 10y times the cube root of 2y plus 7 times the cube root of 2y. I can't add 10y and 7. Okay, 10y plus 7. It's not 17y because they're not like terms. So I'm going to leave it as that. That's going to be my final answer. 10y times the cube root of 2y plus 7 times the cube root of 2y. I can't add them because 10y doesn't add to 7. That's your final answer.